everyone. I'm Dr. Rizwana, working as Professor of Physics. Hello everyone, I'm Dr. Rizwana, working as Professor of Physics in Institute of Aeronautical Engineering. Today we are going to discuss about harmonic waves. Okay, so we must have come across formation of waves along a string. And you'll observe that when wave is formed along a string, then number of loops or number of nodes and antinodes formed in the string, they are going to affect the frequency of vibration of string as a whole. So that particular factor we are going to discuss today in this particular video. So we are going to see what exactly are harmonic waves, how we can generate harmonic waves in a string, and how the frequency of vibration of entire string is dependent upon how many number of loops are formed in a particular string. So as you can see in this figure, and also we are going to come across very important term, the term it is called as overtones. So we are going to get frequency of vibration of a string in terms of its harmonics as well as overtones. Now in this case, what I have done, I have taken a string. So this is our string. And then this particular string, it is fixed at two ends. The string, it is fixed at two ends. And then after that, we made a wave to pass through the string, or we made this string to vibrate. Then you will have propagation of wave through this particular string. And when this wave reaches the other point where it is fixed, then you will have reflection of wave. So wave, it gets reflected back with a phase change along the same string, and because of this there will be formation of nodes and antinodes in the string, and such waves, they are called as stationary waves. So we'll have formation of stationary waves in the string. So how stationary waves are formed? If we take a string which is fixed between 2 points, and then if we make a progressive wave travel through the string, then when this wave reaches the fixed end, it gets reflected back into that string. And because of superposition of these two waves, so one is of course wave that is traveling and its reflected wave, and that reflected wave, it is going to have phase change. And because of superposition of these two waves, we are going to get stationary waves. So what are those stationary waves? Where you will have formation of nodes and antinodes. Now based on number of nodes and antinodes formed, or based on how many number of loops are formed, we are going to define how frequency of vibration of string is going to change. Now if you look at this slide, in this particular slide I have taken three figures. In this figure I am trying to show first case, string which is vibrating with one loop. So what do you mean by vibrating with one loop? Where it has got only one antinode. So what do you mean by antinode? Antinode is maximum amplitude. So it is the place where there is maximum amplitude, that particular position it is called as antinode. And whereas where we have minimum amplitude, or where displacement is zero, that particular point it is called as node. So here when we say that where there is formation of only one loop or one mode, then in that case we have only one antinode position of maximum amplitude. In that case, the length of the string, so that it will take length of the string, because here there is formation of only one loop, and each loop it will have its length equal to lambda by 2. So where lambda is the wavelength of the string. So each loop, it will have length, and that length, it is equal to half of wavelength. And if you take the second case, in second case, as you can see, there is a formation of two loops. So there are two loops forming. It means that I have two antinode positions, and of course three nodes position. In that case, as I told you, each loop, it is going to have length of lambda by 2. So this is lambda by 2, and one more loop length, it is equal to lambda by 2. So what is the total length of this string? Total length of this string is, because there is formation of two loops, so 2 into length of each loop, that is lambda by 2. So total length of this string, it comes out to be lambda. Okay, whereas in the third case, as we can make out that there is formation of three loops, it means that I have three antinodes, maximum amplitude positions, and I have 5 nodes. So again, what is the length of each loop? Length of each loop, it is given as lambda by 2. So here lambda by 2, lambda by 2, lambda by 2. It means that 3 times lambda by 2 is the length of the string. And What you will observe here is when you are trying to find the frequency of vibration of the string. So here we'll say that the string is vibrating with only one mode. So or it is vibrating with fundamental mode of frequency, or it is having only one harmonic, first harmonic. Whereas in the second case, it has got two harmonics because it has two loops. So here this is second harmonic, and if you want to define it in terms of overtone, it will become first overtone. And whereas in the case of three loops formation, we'll say that third harmonic or second overtone. So if you try to get its frequency, now if you see here, one important point as I told you, so if a string which is fixed at both ends and stretched, then there will be formation of stationary waves. And why these stationary waves are formed? Because of interference of reflected waves with phase change from both ends. And frequency of vibration of string, it depends upon number of modes formed between two ends of the string. And what we'll observe here is string, it is going to vibrate with all possible harmonics. Those loops are nothing but our harmonics. And how to find frequency of each harmonic? Frequency of each harmonic, it is integral multiple of fundamental frequency. Now here, as you can see, what is the fundamental frequency? Suppose if your string is vibrating with only one loop, then fundamental frequency or first harmonic, it is given as 1 by 12 square root of T by mu, where T is the tension. So string, it is subjected to tension T, and what is mu? Mu is linear density of the string. And suppose if my string is vibrating with two loops, then you will observe that it is called as second harmonic, and then its frequency, it is given as, because there are two loops, 2 into what is the frequency of each loop or first harmonic, it is 1 by 12 square root of T by mu. So 2 times the fundamental frequency. So if 3 loops are formed, then our frequency will be 3 times the fundamental frequency. So we'll observe that, so frequency of vibration of string, it is integral multiple of fundamental frequency. And here this is, we are saying it as second harmonic, or we can also say that it is first overtone. Here we are talking about first overtone, and this one third harmonic, or it is called as second overtone. Now this is what we got, and this equation is very important equation. With this equation, we know that there are 3 laws of stress string. So what are those 3 laws? As we have seen that, what is the formula for frequency? Formula for frequency, it is given as 1 by 12 square root of T by mu. Now, in first law, how frequency and length are related? Frequency, it is inversely proportional to length of string. That is our first law. And second law is frequency is directly proportional to square root of tension. And coming to third law, frequency is inversely proportional to square root of linear density. What is the use of these 3 laws? So you'll observe that we can change frequency of vibration of string by changing length, or by changing tension, or by changing linear density. So this particular laws, they will be using in laboratory, physics laboratory. So if we are able to recollect, there is one experiment, Melodies Experiment. So in the Melodies Experiment, we'll have electronically activated tuning fork, and in order to find a frequency of vibration of the tuning fork, to one of the prongs of tuning fork, we are going to connect a thread. And because this thread is in contact with the tuning fork, this thread will also start vibrating. And this thread, it is taken over a pulley, and at the other end of the pulley, we'll have one pan. In that pan, we are going to add weights. Now what we'll do, once tuning fork is made to vibrate, then along with tuning fork, thread is also going to vibrate. Now what I'm going to do, I'll make tuning fork and thread vibrate with the same frequency. How? By changing frequency of vibration of thread. How can I change frequency of vibration of thread? Either by changing its length, or by changing tension by adding weights in the pan, or by changing material of the thread. So I will keep on changing frequency of string until tuning fork and thread are in resonance. And easily that we can make out when there are formation of well-defined loops in the string. So at that particular stage, it is easy to find frequency of string using this formula, and we can say that frequency is nothing but frequency of tuning fork, because both tuning fork and thread, they are vibrating with the same frequency. So now, in this particular slide, we are going to see based on length and number, based on the length of the loop, so length of each loop or length of the string, and depending upon how many number of loops are formed in the string, how we can get to this expression for frequency. So already I have told you that if there is formation of only one loop, then length is 1 times lambda by 2. So if you take 2 loops, 2 times lambda by 2, 3 times lambda by 2, it means that length. Suppose if there are formation of n loops in the string, then length of the string is n times lambda by 2. So once I got length, from this I am going to write formula for wavelength. So wavelength is 2L by n. And how to write this wavelength? This wavelength, I'll write it as, we know that wavelength, it is nothing but velocity by frequency. So here, so that's why your frequency, it will come out to be, so this is velocity by frequency. So this, when we take this, then what is our frequency? Frequency will become n into velocity by 12. But we know that velocity of waves through a string, it is given by f by mu, or we can also take it as tension by mu. So finally, so what is our frequency? Frequency, it comes out to be n by 12 square root of t by mu. So what we have done, by taking length, and that length based on number of loops formed, we try to get frequency of vibration of the string. So today we have discussed about the formation of different loops in a string by superposition of instant wave and reflected wave with a phase change, and depending upon notes and antinodes formed, how frequency of vibration can be expressed in terms of its harmonics as well as overtones. So I'm going to end my session here. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.